Let's do it again. I am here to talk about carbon neutrality, which is the first goal, the overarching goal. And if you've been listening to all the wonderful stuff that's been happening, it's all to drive carbon emissions down. I want to start, instead of ending with acknowledgments, because you've probably seen along the way that this takes a bunch of people. This is not just my stuff. It's mostly other people's stuff. And I'm talking about it, but without campus planning, without Simona's help, she's really driven the 2021 carbon inventory. I did the 2019 inventory with a bunch of students. John, who was here, did all of the inventories before that for like a decade. This takes a lot of people because the information I'm going to show you in like 15 or 20 minutes is totally the tip of the iceberg. There is so much data below it, as Steve was saying. Hundreds of buildings, meters, data coming from everywhere. The Office of Sustainability has been great. You probably won't thank yourself, so I will thank you guys for putting this on, because for the students who are in here, this is amazing, because I come in and I've done this for a long time and I still learn something from every single one of these presentations. This is a really great opportunity, and we've got a really good partnership. And as I said in the last one, we really have to recognize both past and current students, because the students are what drove us to redo our climate action commitment in 2020, and they're often one of the driving forces to get us to do more than we were going to do, and they're a key stakeholder, and they've been helpful. So this is really great. Okay, you've seen all of these things. What we're talking about right now is carbon neutral. So how do we put all of these improvements together to reach a carbon neutral campus by 2030? There is a report that's published already from 2019. The 2021 report is more or less done. It's in graphics design, getting finalized. So if you go to the Office of Sustainability, you can download this one. And I'm guessing the 2021 version will come by the end of the semester if we're lucky with the graphics folks. So a lot of the stuff that I'm talking about are just summaries from this and the new one, which isn't quite published yet. You can't tell here, but after my name here is like 6 or 7 students. We did an independent study, and all of those students were the folks who actually entered data into the software platform that we're using. They did some of the analysis, and they helped us write that report. So as I'll say at the end, if you're a student and you're interested in helping, we can find a place to plug you in. There's lots of work to do. So if we've got a carbon neutral goal, we probably have to start with what are we even talking about in the first place. This is a schematic of a system, and that system has upstream activities and downstream activities, and carbon systems are divided by protocol into these 3 different scopes. Scope 1 is direct energy use, so this is fuel used in the fleet, natural gas used in boilers and in buildings. These are direct use of fuels, which when you burn fossil fuels, you get emissions into the atmosphere. Scope 2 and 3 are not direct, they're both indirect. The difference is that Scope 2 is electricity. We are actually generating electricity ourselves because we have a power plant, but most places are just buying electricity from a utility. And even though the utility is generating the emissions, there are responsibilities. So all of those get called Scope 2. And then Scope 3 is this wide range of everything else, getting stuff to and from campus, commuting, dining halls, all of this other stuff, which is a little bit harder to measure and often is a smaller portion, is considered Scope 3. And any kind of emissions we give off end up in the atmosphere, and this is a subset of the primary gases that are greenhouse gases. These are gases which, because of their chemical nature, absorb radiation and heat the atmosphere up, causing global warming. These are not all of them, but these are the primary ones. Carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, and perfluorocarbons. These are mostly in refrigerant systems. SF6, which is in transformers and electrical distribution systems. There's a handful more, but these are the primary ones. Carbon dioxide is the dominant one, and that's where we come up with this general term that we talk about is carbon footprints. That's essentially synonymous with greenhouse gas. And what you're doing is you're analyzing the sources and the amounts of all of the greenhouse gases given off in Scope 1, 2, and some of Scope 3. You can do this for a product like a shirt or a computer or a car. You can do it for a process like generating electricity or 3D printing some mascot. You can also do it for an entire system, which is campus's buildings and travel and stuff. So this greenhouse gas footprint is trying to encompass kind of most of the things that happen on campus. These are necessarily incomplete. You can't account for everything because you'll never finish the accounting. What you're trying to do is pick the easiest ones to measure, the biggest ones that you can influence, and spend a reasonable amount of time to get close to an answer. It doesn't make sense to over-scope. So what we had to do is decide where we draw boundaries around the campus. Our scope for this and all assessments going forward is net zero annual emissions. This means either not emitting stuff, or if you are emitting some emissions, you're offsetting that by sequestering some carbon in another place or by another process. So we are only looking at these three main chemicals initially, CO2, methane, and N2O. For all operations for lands and buildings on the main campus, including buildings leased by departments in Blacksburg. The university leases a lot of buildings that they don't own, but we still use energy, and it's our responsibility. And we are also including agriculture and forestry across the Blacksburg region. That is most of what you would consider the campus, but not all. If you look at these two tables, you can see before the 2020 Climate Action Commitment, we were still doing greenhouse gas inventories. John started them over a decade ago, and in those, you can see these main things were in, and a number of these things, some of them in Blacksburg, some of them not, were out of scope. When we included the new scope, the big addition was including leased buildings, buildings not owned by the university. This was not in the previous greenhouse gas assessments before 2019. So this is kind of geographical scope. These are operational scopes. So you can see energy and buildings and water and waste and travel. And what we've added since the old scope there is we've added losses of electricity as it's generated and shipped across high transmission lines and low transmission lines to buildings. Leakage of natural gas. This is a big thing that the students were pushing for. Natural gas is often said to be less carbon intensive. That's only when you're burning it. If it's leaking out on the way, even in small amounts, it has a huge global warming potential, meaning it grabs heat more efficiently, grabs radiation more efficiently than carbon dioxide. And so this was included in an estimate. And then we've included a whole bunch of things which were out of scope before as well. The buses, university travel, dining systems, composting, and a bunch of agriculture stuff. So this is the scope, everything in green in this second column, and that'll be useful as you see the data. There are two pieces of the scope here which are worth mentioning, which are starred. They are planned to be in the assessment, and we have agreed to do them as part of the Climate Action Commitment, but due to data analysis and other issues, resources, we haven't done them yet. So they're in the queue, ready to go. And we heard really good talk this morning about urban forestry, and we can pull that data in pretty easily because they have a pretty good data system for the trees on campus. Okay, so all scope 1 are included, all scope 2 are included, and most of scope 3. This is what it was just shown in that table, but this just shows it kind of in a bulleted sense. And the dining hall and the forestry information is given there. So what does this look like? Before, this is directly from the Climate Action Commitment. This was the commitment to go forward. These are the historical records. Okay, this is business as usual if you don't change your behavior. And this is the first few years of behavior change after the 2009 Climate Action Commitment. And you can see that we were coming down pretty sharply. The 2009 commitment only required 80% reduction by the year 2050. And at the time when that was passed, that was considered a pretty strong goal. And over the intervening years, that goal started to look less strong as sentiment in general changed, like we need to move quicker, and other universities started moving quicker. And so the difference between this 2009 goal and this carbon neutral goal here, this really steep slope here, this is what the students were pushing for, saying this is not good enough. I mean, look at the gap between this point and this point in 2030. So you can see we have some data suggesting that we should be able to follow this line down, and you've heard lots of stories about savings of emissions and dollars and improvements in efficiency. The one thing to really remember and to emphasize is that each year it gets harder because you do the stuff that's the easiest and the most cost effective. So the stuff we have to do next year, as Steve and Simona will tell you, is harder than the stuff we did this year. And then the year after that, it's even harder. So maintaining this slope is going to be a challenge, and that's the challenge we've all signed up for, and the challenge that all these people you've heard talking to are going for. So that is kind of the big picture. This shows the results of the 2019 analysis. This is just a summary table to give you a sense of all the data. You can see the scopes here and you can see this from total greenhouse gases down. And here's a pie chart to make it a little easier to see. So you can see purchased electricity is just almost half. And when you add in the power plant and all the heating and cooling and district work there, you're almost up to kind of 70% here. And then you can see the other things like travel and agriculture and these other things, which are smaller pieces of the pie. And this is useful because it tells you where to start. It's kind of like a budget, right? If you're trying to save money, the question is, am I spending too much money on clothing or going out to dinner or housing? Right? If you don't know where the money's being spent, you can't decide the best way to save it. The same thing with energy. You look at the biggest chunks of the pie, then you do a secondary analysis that says how much does it cost me to reduce that piece of the pie, and the biggest savings for the least cost are the kind of things you go after. But this quickly gives you a sense of where our needs are and where we're going. And you can also see, if you read here, it's split up into carbon dioxide, methane, and nitrous oxide. And carbon dioxide is almost 90%. And this is why we call these things carbon footprints. So that's the 2019 analysis. 2020, we didn't do a full-blown analysis. Operations were suspended or reduced for COVID. The data collection was not as good. We didn't do a full-blown analysis then. We've put some data collection things in place, so it's easier to get the data year after year, right? This can take a lot of time unless you automate some of this. So Simona and I have been working to make this easier. The goal is to do this every year. So if we look at the 2021 data, and you look here, you will see that this looks more or less the same. The pie chart is rotated, the colors aren't the same. Hopefully the graphics folks fix that so it's consistent. But you can see one difference is that the purchased electricity number is now, instead of at 44, it's up around 53, a little bit higher. The main difference here is that in 2019, we were able to purchase renewable energy credits from the hydroelectric dam that's at Claytor Lake, which AEP runs. And in that case, you get to subtract those carbon emissions because they're coming from a low carbon source. We didn't purchase those renewable energy credits in 2021, so those show up in the electricity part of the pie. But if you add the electricity that we buy and the electricity and heat and cooling that we generate, it's about 75% of our emissions. And so that's why a lot of the talks this afternoon are on buildings and systems and places where electricity and heat and cooling can be improved. You can also see there's a lot of things one could draw from this, but it is interesting if you look at commuting, for example, even though faculty and staff is a much smaller number than students, faculty and staff commuting numbers are higher. That's two reasons. One, students are more likely to use alternative transportation in the buses, and faculty are more likely to be driving from further away and maybe not carpooling. So there are opportunities. Everybody needs to chip in to reduce these things, but you can see these things. You can see travel. Solid waste is a very small slice. You can also see that this methane leakage, this number here is a bit more of an estimate than some of these. There's a bit of uncertainty in all of this data, but we really can measure electricity, steam, natural gas at a high level. The amount of methane that is leaking between the utility and here is a harder number to come by. Nobody's measuring that. So we've used the best estimates from the literature, which says about 2% of all of the methane that goes into the system doesn't make it to the end. And that 2% turns up to be a bigger piece of the pie because the global warming potential of methane is 25 times higher than CO2. In a 100-year analysis, this is a 100-year analysis here. If you go to a 20-year analysis, a shorter-term one, which some people argue is better since trying to hit our goal by 2030, methane has a global warming potential of about 80, and the piece of the pie would be bigger. So in the short term, methane is actually a better approach than some of these other ones because in the short term it has a bigger number. Now, as opposed to some of these things like electric vehicles and new buildings which require technology, methane leakage does not require technology. It requires better operations, better logistics, and just better awareness of where the methane is going. So that's not technology limited, it's more limited by systems. You can also see fertilizer. We're a rural campus and we have animals and grow food and do dairy products, so all of that shows up here. And this is one of the this slice here is a big piece of the nitrous oxide part of our greenhouse gas inventory. If you look at an analysis over time, you can see this trend downward, which was that trend you saw in the original graph, and you might be disturbed by this increase here. What we did is we added scope, if you remember. There's a whole bunch of pieces we added in. So it's not like what has happened here is it didn't increase by this much. We didn't count for some of this stuff in these previous years. So we're counting for much more of the systems now, and so this is our new scope. 2020 was kind of a funny year just because operations was a little bit less. And you can see 2021 looks a little bit higher. This would be lower if we had those renewable energy credits in there as well. We have added, remember all of these years too, we're adding facilities and floor space. So we are, when you see decreases, those are absolute decreases and big increases per unit of space on campus. So that's the other catch in this, is you've got to reduce these things while campus is trying to grow, which is a big challenge. So from now on, at some point we won't look so much at this data. We'll be using 2019 as kind of our new baseline, and we'll be going forward from there. The last thing to say is that we've got a bunch of pathways to get to those goals. This was more applicable this morning when people hadn't heard about all the pathways, but now people have heard the pathways. But the point is, our climate action commitment is different than many of the other university commitments in that it's not just a set of goals, but there are strategic pathways to get there. The easy thing is to say we're going to reduce carbon emissions by X. The hard thing is to actually have a plan to get there and to follow that plan. So one of the things the climate action commitment was really focused on was actually being sure that there was a reasonable path to get there. And it wasn't just a number thrown out in the sky to make people feel good about it. So these goals are goals that you heard quite a bit about. If you were here earlier this afternoon, you can read these if you weren't here and you haven't seen them. But essentially, we've made progress already. These are pulled from the original report. This suggests that going to complete natural gas will reduce emissions by about 10%. This is already done. No coal burnt since fiscal year 2020. Buildings, we just talked about, another 10% if we do all of these adjustments to buildings, both fix the old building systems and improve the new building systems. We've got waste recycling, transportation, agriculture, and forestry. There's another 10%. Renewable electricity by 2030, which is goal number 2, can drop things by 50%. And the important thing that John Randolph mentioned in the first session this morning was that while all of this stuff is happening on campus, it's in conjunction with changes that the state and the utilities are already making. So if you look, the utilities have this steep curve of dropping their carbon emissions. So everybody's pulling in the same direction, and those things will help us as well. So if you look at this, you can see 50, 60, 70, 80. We're starting to get closer to how we're going to hit this number. This doesn't even include the electricity we're getting from outside coming from renewable sources. And then finally, realistically in 2030, the reason we use net zero as the goal is because the timeline is so short. It's a bit unrealistic to say we're really going to have no emissions by 2030. And the question there is, with those remaining emissions from some vehicles that are not electrified, some building heating systems that are still using natural gas or whatever, we can either develop or purchase some carbon offset. So someone else will be pulling the carbon into the system and out of the air, and we pay for that service. We prefer to develop these things ourselves. So there are options to use agriculture and forests and other things to sequester carbon. So we would prefer to do that on our own rather than pay someone else to do it. but there's always the opportunity in this growing market. In some cases, the economists like the fact that there are people who can do this much cheaper than you could do it. So from kind of a utility point of view, there are some arguments that somebody who could do it cheaper will allow more money to be used in other areas for other things. So that's an area of debate still, and we're going to drop this number as far as we can before we even really decide what to do here. But like everything else, we need to kind of have plans for what's even an option for carbon offsets before we get there. So we're not surprised by where they're coming from or how much they cost. And John kind of referred to that. Anything you leave on the table in 2030, if you want to hit your commitment, you have to do something with the difference. And that potential cost might spur some action in advance, where people are saying, wow, in 2 years we got $10 million worth of offsets that we need. Maybe we should do something that has return on investment for us on campus, today. Mm-hmm. So that's a quick synopsis of how we get there. Just to finish this up, often we sit in these things and it's always like somebody over in that building in administration needs to solve these problems, right? Or the government needs to fix it for us. And what I hope you've seen is that there are a lot of administrators and people on the ground doing stuff on campus, but we all have some responsibility here to reduce, to conserve, to do things differently. So if you're not involved already in anything over the course of this day has piqued your interest, please reach out to individuals or talk to our great folks at the Office of Sustainability, and we will hook you up with some. There's a lot to be done, and there are lots of projects, and you can learn a bunch of stuff at the same time. So please reach out to folks and join us. I've almost caught us up, but we do have time for some questions because I went through this fairly quickly. Some of you have heard this twice now. But any questions or comments?
I'm just glad someone's working on this. It's not something I'm too terribly involved in. It's so important, and like, just grateful that I have this to use to help me in my job. The inventory, and to understand, what the trends are, and where the targets are, and very, very helpful to have. So.
Well, it's a team effort, which is the thing to know, which is if you don't have this as a starting point, Steve's not sure where to start, what to do, how to do this. And it's from my point of view, I like collecting this kind of data. It's where my skill set, and when I see Steve talk about, hey, if I do this, that, and the other to the building, we can take that wedge and cut it in half. I'm like, wow, that's exciting. So it takes a bunch of people working on different pieces of this. But one of the reasons we did this first thing this morning is that if you don't have a roadmap of where you are for anything, you can't figure out where you're going. And so this was the starting thing that says, this is where we are, this is where our emissions are, this is our opportunities. Now we look at experts in all of these individual fields to say, how does my piece of how does transportation fit into this? How does agriculture fit into this? How does facilities fit into all this? So it's been great to work with Steve and all the facilities folks. So fun. Other questions?
So the
Yes.
The natural gas leakage.
Mm-hmm.
My understanding, right? You basically just you take the total cubic feet or whatever it turns and apply a multiplier to it.
We do for the direct. So the things the stuff that's burnt in the building, if we know how many therms we use, we add back 2% more, assuming loss from the building all the way back.
Right.
That goes all the way back, in fact, to the mine as well.
Yeah.
There's some loss happening at the mine, and there's some pretty good data out there, and the EPA is trying to get better data. So that's the first half of it. The second half of it is the electricity we buy from AEP is also using natural gas to generate some fraction of their electricity. So we take the electricity we use, we find out what fraction of that was generated from natural gas based on the fuel mix from the utility. And then we take a smaller piece of loss because the utility is getting it directly. They're not having to ship that natural gas all the way to campus. So there's many more places to lose electricity from the utility to Burris Hall than there is from the utility straight to a power plant in West Virginia. Yeah. So there's a smaller loss factor applied to the utility for the indirect loss and a slightly bigger number. And as I said, both of those are We can change those and see how the data changes, but a couple percent is the number that people are using based on two kinds of measurements. Satellite measurements, looking at methane from the sky, and also measurements from the utilities themselves saying, I measured this pressure here and this pressure here, and I've lost this much along the way. Right. The utilities know how much they generate and how much they can charge you. And so the loss between the utility and your house is real, because they can't charge you that. It doesn't hit your meter, but they sent it to you.
Yeah. So just anecdotally, I was at our steam plant a couple weeks ago, and I think one of the operators was explaining like the startup sequence on our boilers, and it's not instantaneous, right? So there is a little bit of gas that gets unburned, so it's like the more that boiler cycles on and off, you're going to have some loss.
That's a great point.
Which, that wasn't something I hadn't thought of it that way before. So I guess that might be a little bit too granular, really, for this level of analysis.
Probably, but that's built into the average. But as you and Steve were talking about, like those steam traps where you can lose some stuff, some of you may notice this at your house if you've got natural gas in some kind of heating system. If you're outside near that vent, there are times when you can smell some of that mercaptan that's in the natural gas. What that means is your system's probably not tuned up. It's running a little bit rich, right? And so just like you were saying, in all these buildings, there are things that, over time, this is why you get your boiler at your house checked.
Yeah.
And these things are important to do because they're safety issues as well, right? You collect too much methane and you can have an explosion.
Mm-hmm.
So that's why the mercaptan has been added, so people know that smell, right? Natural gas in and of itself is odorless.
Yeah, and I guess since we started putting more condensing boilers in buildings like D&DS, right, in the penthouse, it's like, yeah, you got to know to check up on that kind of thing.
Yeah, the flue gas should be odorless, colorless.
Yeah.
Shouldn't smell like anything. If it has a smell to it, then the combustion efficiency isn't great. Yeah.
Other questions? Yes?
I'm curious, so you talked about things from a systems perspective in terms of the campus, but we're thinking like big picture outside of the campus. What does the collaboration look like between Virginia Tech and the different, Montgomery County as a whole, Blacksburg, Christiansburg, when it comes to things like carbon neutrality? Because a lot of those things are out of our hands. Like for instance, you talked about staff, people who live far away. Are there efforts to build, I know we talk about building dorms for students all the time, but I'm like, are they doing anything with faculty or staff, and even like bigger systems like transportation are really big for carbon, and I know they're talking about a train, the Amtrak is going to be extended to Christiansburg. Do you see your report being used by other organizations to try to push for more carbon neutrality in a bigger area?
I don't see that yet, but there are partnerships that we already have with townspeople that are aware of these issues and see this. And in some cases, some cities and towns have never done anything like this. So if they see something like this and realize it's possible, so I've done this for the city of Roanoke for many years, and Blacksburg has their own people doing this kind of, but Christiansburg is probably not doing this. So there are these partnerships, but as you pointed out, we're trying to account for everything, but we are not accounting. If you live in an apartment off campus, that's not in this carbon footprint. We can't collect that data easily, and it's really happening in the town, not on campus. So there are these ancillary pieces that, while the commute we are trying to account for, there's these other pieces that aren't. So as far as we can leverage these other things, like busing systems and charging networks, I think all of the independent groups on campus are trying to take advantage of those, because it's not just our campus that needs to be carbon neutral, it's the whole country, the whole world kind of thing. So I see partnerships coming. Some of them are faster and some of them are slower. Like the bus system here has got a really good partnership with us. And there are other places, like we probably don't have a great partnership with landlords off campus. They probably don't have, super efficient systems, right? All of these kinds of things. They're not monitoring any of that. You're maybe paying extra because you have really inefficient heating systems. It might not be as safe as you want. So there are more opportunities that we could take advantages if we can make the connections. And I know I'm looking for those connections, and I know other people are as well. But everybody's got little ideas, so if you can help us make connections, that's great too. If you start with one landlord who you can say, hey, you could save some money if you had more efficient systems, right? And it would save the students, and it would help the climate, and it would be safer, right? Maybe you can get the snowball rolling, right? That's the hope, at least, that somebody gets excited about this. As excited as Steve gets about boiler systems.
Right, right, yeah.
Other questions? Well, if something comes up to your mind, let me know. If you're interested in helping with the greenhouse gas inventory, we've got some parts of it that we haven't completed yet that we need to, like the dining hall food. And we're going to add the tree canopy sequestration in there. But thank you, guys.
Thank you.